Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. So we will wait for 2 minutes and then we will start the lecture. Just tell me whether my screen is visible to you. Yes, whether the screen is visible?
Yes.
Okay.
Yes.
Okay, so we will wait for 2 minutes, let the all participants join, and then we will start with the lecture. Okay. So in the previous lecture, we have seen the rotation about an arbitrary point and reflection about an arbitrary line. So for rotation about arbitrary point, we have seen as the rotation matrix available with us is with respect to origin. And if we want to rotate any object with any arbitrary point in XY plane, then we need to follow some steps. And that steps we have studied already. They are just translate that point, any arbitrary point, to the origin, then perform the rotation, and then translate the point back to its original location. So that we have studied rotation about arbitrary point. Similarly, we have seen the reflection about arbitrary line. So for that, we have seen the reflection matrices available with us are reflection along x-axis, reflection along y, reflection along y equal to x, and reflection along y equal to minus x. Apart from these four, if you have any axis and you want to carry out the reflection with that axis, then what will be the steps? So for that, we have gone with, or we have studied these 5 steps. So first is, so we have, if you remember, we have drawn a diagram like where the reflection is available only with respect to x, y equal to x, and y equal to minus x, all the lines passing through the origin. But if any random line is there, for example, this line, and I'm having one triangle, and I want to reflect this triangle with respect to this line, line L. So for that, what are the steps to be carried out? That is explained over here. So first step is you have to translate this line so that it will pass through origin, because all our lines for which the reflection matrix is available, all of them, they are passing through origin. So we are meeting those requirements. So shift this line so that it will pass through origin. So by this much amount, so this is nothing but your intercept with y-axis. So you have to shift this point downwards so that the whole line will be now passing through the origin. So step number 1 is over. Shifting of the line, translate the line such that it will pass through origin. Second is, now you have to rotate it. You have to rotate it so that it will coincide with either x-axis or y-axis. So you have to rotate this with this much angle. So that is for this angle, for this much angle, you have to rotate the line in clockwise direction, so that now this line L will coincide on x-axis. And as that is present now on x-axis, you can carry out. So rotation is over, rotation, and then we have the reflection matrix along x-axis. Then carry out the reflection and do the reverse process. That is the inverse rotation and inverse translation. So reverse the rotation and reverse the translation effect. So these are the 5 steps we have to carry out for executing or for solving these type of problems. Okay, so let us see the example of this now. So we have seen TR, translation matrix, rotation matrix, reflection, rotation inverse, and translation inverse. So these are the 5 steps. Okay, so now this is the example. Okay, so example given is, we have to reflect a triangle ABC with vertices A00, B11, and C23 with a line 3x minus 4y plus 1 equal to 0. So we have this expression of the line. Line equation is with us, and with this line you have to reflect this triangle ABC. Okay, so I will draw the diagram somewhere. Okay. So this is 0, 0, 1, 1. So I will draw the object first, and then we will consider about the line where it is passing through, how it is passing, like that. Okay. Okay. So I will use separate color for showing the triangle. So triangle ABC with vertices A0, 0. So this is your A point, then B11. So this is your another point, B11, and C is 2, 3. So 2 and 3 somewhere over here. So you are having the or we may do one thing. Instead of this, we can change the coordinates of the triangle so that it will be easier for us. To view that triangle. So here I will have 2, 2. Then here I will have, suppose, 5, 2. And here I will have 3, 5. Okay. So we will draw the triangle with respect to these values so that it will be easier for us. So now I will draw again. Okay. So okay. So first point is 2, 2. So 2 and 2 somewhere over here. Then I'm having 5, 2, 3, 4, 5. 5, 2 is here. And 3, 5. So 3 and 5 somewhere over here. Okay. So this is my triangle. Triangle ABC. Okay. Right. So this is my A point, B and C respectively. Now I am having this line. With respect to this line, I have to reflect this triangle. Okay. I have to reflect this triangle with respect to this line. So I will arrange the terms in such a way that the expression will be equal to y equal to mx plus c. Okay. So I will arrange the terms. So 4y, I will pass this side. So I will get the expression as 4y equal to 3x Am I audible now? Due to internet issue. Yeah. Due to internet issue, the connection was lost. Two, 2, then 5, 2 we have taken. 5, 2 and 3, 5. Okay, so we have this triangle ABC and we want to reflect it with 3x minus 4y plus 1. So I will rearrange the terms. Simply rearranging the terms, 4y this side. So I will get 4y equal to 3x plus 1. Then divide with 4. So I will get y equal to 3 by 4x plus 1 by 4. All of you agree with this? Y equal to 3 by 4x plus 1 by 4. Up to this, is there any difficulty? Okay. So if I compare this expression with the expression of the line y equal to mx plus c. So when I compare these two things, what will be the output? M. What is the m value? It is 3 by 4. And what is the c value? C is 1 by 4. C is 1 by 4. Okay. So this is the expression I am getting. Now to draw this line, I can put some value of x and I can get the value of y for it. So consider if I am putting x is equal to 4. So for x equal to 4, what is the corresponding value of y I will be getting? 4 will get cancelled. 3 plus 1 by 4 is the result. So a point that I will get is, the point on the line is x value 4 and y value is 3 plus 1 by 4. Okay. And similarly, when I will put some other value like let us assume x, if I will take x is equal to minus 4 or x is equal to 1. So when I will put x equal to 1, then 3 by 4 plus 1 by 4. 3 by 4 plus 1 by 4, that is 4 by 4. So y will be also equal to 1. So I have got the extent that the line is passing through these 2 points. Line is passing through these 2 points. So I can draw this line. So 1, 1 is the point from which the line is passing. And the second point is 4 and 3 plus 1 by 4. So 4 is this point of, that is x, and 3 plus slightly upper. This is your 3. So almost on 3 itself, the line is there. So I will take slightly above. So this is your line. Now it is passing through these 2 points. So I will extend these 2 points. Bear with the drawing. Okay. So this is the actual line L. And we want to carry out the reflection about this line L. Okay, all of you are getting this? Yes, respond whether you are getting it or not.
Yes, ma'am.
You want me to repeat this again? Yes, anyone, if they want me to repeat it, I will repeat.
Yes, ma'am. Repeat it.
Okay, so we have a point 2, 2, we have B point 5, 2, and we have C point 3, 5. So what we have done, we have drawn this triangle ABC, and we have this expression of the line. Now this line, I have rearranged the terms for this line and I have got the result as 4y this side and 3x plus 1 this side. So 4y equal to 3x plus 1 is the expression I have received. Then I have divided every term by 4. So I am getting y equal to 3 by 4 x plus 1 by 4. Up to this, is there any difficulty?
No, ma'am.
Okay. Now, when I compare this expression with line expression, what is the expression of line? Y equal to mx plus c. So when I will compare this, what am I observing? M has the value 3/4. M has value 3/4 and C is 1/4. Okay. So M is 3/4 and C is 1/4. So we have reached to this particular conclusion. Okay. Now, I have got the slope of the line and I have got the intercept also. So slope of line is 3/4 and intercept is 1/4. Now in the same expression, in the same line expression, if I will put some x value, I will get the y value, corresponding y value. For example, this is expression in which I am putting x value equal to 1. So put x value here. X is 1. So 3 into 1, 3 plus 1 is 4. So when I put x is equal to 1 on the right hand side, I will get 4. And on the left hand side, I am having 4y. So what is the value of y? Y is equal to 4 divided by 4. So I will get 1. That means when I put x is equal to 1 in the line, I will get y also 1. So a point on the line is 1, 1. Is it clear now?
Yes, ma'am.
Okay. Similarly, I am going to put x is equal to 4. So when I put x equal to 4, 4 will get cancelled. And I will get 3 plus 1/4 as my value of y. 3 plus 1/4. Okay. So I have got these 2 points. Now when 2 points of the line are known, can you draw the whole line? Yes. So I am having this point 1, 1 and this point 3, 4, x value 4 and y value is 3 plus 1/4. So it is almost 3 only. So it is 3 plus 1/4. So it is almost 3. So when I join these 2 points, I will get this line. Now it is okay. Okay. So this is your line L, which is having this expression 3x minus 4y plus 1 equal to 0. Now what is our job? The given triangle we have to reflect with line L. We have to reflect with line L. It is, though it is intersecting, it is going to produce some reflection. जरी हे इंटरसेक्ट करत असतील तरी हा पॉइंट या साइडला येईल मग रिफ्लेक्शन नंतर आणि हे 2 पॉइंट्स या साइडला येतील. इट इज सेम ॲज दॅट ऑफ फोल्डिंग द ट्रायंगल ऑन द लाईन इटसेल्फ. So I am going to fold that on the line and you will get point A and point C on this side, right hand side of the line, and this point B will come here, somewhere over here. So let us see whether we are getting the same results after solving the problem. Up to this now, is there any difficulty? All of you are understanding?
Yes, ma'am. Yes, ma'am.
Okay, boys side.
Yes, ma'am.
Okay, so now this slope is with me.
Yes, ma'am.
Okay, now the slope is with me. What is the formula for slope? How to calculate the slope? It is tan of theta. Can we write the tan of theta? Slope of the line is tan theta, right? We are having the formula m equal to tan of theta. And that value is already known, that is 3/4. What is tan theta? Tan theta, it can be written as perpendicular side. It can be written as perpendicular side divided by base, right? Tan of theta. If this is the angle theta, can you tell me the tan of theta, this side, which is perpendicular, opposite side divided by adjacent side. So I can say P, it is the perpendicular side, and B, it is the base. Can we say like this?
Yes, ma'am.
Right. So this P will have value equal to 3 and this B will have value equal to 4. Now, as I am having this, can I find out the sine theta and cos theta? For that, I should know this hypotenuse. So you know the Pythagoras theorem. So can you tell me the hypotenuse value?
5.
Yes, it should be 5. Now tell me what is cos theta and sine theta. So sine theta is opposite divided by hypotenuse. So 3 by 5. So sine theta will be 3 by 5 and cos theta will be the adjacent divided by hypotenuse. So adjacent is 4, hypotenuse is 5. Okay. Now we have got sine and cos value. Why we need that? Because we want to rotate this line, isn't it? We want to rotate this line. And for that only sine theta and cos theta are required. Getting this? So what we have now, we have this C, that is the intercept. So this intercept is on y-axis. Okay, this intercept is on y-axis. So what are the coordinates of this point? Can you tell me? X value, as it is intersecting y, X value is 0, right? And C value is 1 by 4. That means this intercept is 1 by 4. So this distance is 1 by 4. Okay, so it is a C intercept. So this point is having coordinate 0, 1 by 4. Now I have all the requirements with me. Okay, now I have all the requirements with me. That is by how much amount the line to be shifted downwards. Right? Because I want to shift this line so that it should pass through origin. And I know by how much amount I should shift the line. So first is the translation matrix. So can you tell me the translation matrix now? We have 5 steps with us. First step is translation. So I will say T translation. So can you tell me the T translation? The translation matrix is
1001.
Okay, correct. 100 010
01.
And the last, these two are translation along X.
1.
So here translation along X, whether it is required? No, X value is already 0. So in order to pass it from origin 0, 0, X is not required to change. X is already 0. So there is no change in the X. So I can say no change in X. Here translation along X is 0. But what is translation along Y? You have to shift that Y downwards. Downwards means minus 1 by 4. आता सध्या 1 by 4 ही व्हॅल्यू आहे लाईनची, बरोबर? आणि ती मला 0 करायची आहे. म्हणजे काय करायचं, मला त्याच्यातून -1 by 4 करायचं. 1 by 4 - 1 by 4 इट विल ऑटोमॅटिकली गिव्ह मी 0. सो दिस इज युअर ट्रान्सलेशन मॅट्रिक्स. कळालं हे सगळ्यांना?
Yes, ma'am.
Yes. Now this line will be shifted downwards so that it will pass through origin. आता मला काय मिळालंय? लाईन. आता लाईन ओरिजिन मधून, म्हणजे हे ट्रान्सलेशन केल्यानंतर आता लाईन ही माझी ओरिजिन मधून पास होतीये. ओके. हा. सो आय हॅव गॉट दिस रिझल्ट विथ दिस फर्स्ट ट्रान्सलेशन. आता काय करायचंय, मला या थीटा अँगलनी रोटेट करायचंय in clockwise direction so that it will lie on x-axis. बरोबर? So the second operation is T rotation. So perform the rotation. आणि ते पण काय करायचंय, क्लॉकवाईज रोटेशन आहे विथ थीटा. सो क्लॉकवाईज रोटेशन साठी टी मॅट्रिक्स काय असणार आहे तुमचा?
cos theta
येस, कॉस
sin
थीटा,
theta
करेक्ट.
sin theta minus sin theta cos.
Here minus sin theta
Cos theta.
and cos theta. Okay. Here it is 0 and here 0, 0, 1. Okay. All of you are getting this? Then next, आता काय झालं, रोटेट केल्यानंतर ही तुमची लाईन विल कोइन्साइड ऑन एक्स. सो एक्स आणि एल हे तुमचे सेमच झाल्या. ही लाईन या एक्स ऍक्सिस वर कोइन्साइड होईल. आता इथे साइन आणि कॉसच्या टर्म्स मी ऑलरेडी फाइंड आउट केल्यात. साइन थीटा म्हणजे किती आणि कॉस थीटा म्हणजे किती आहे. सो डायरेक्टली पुट दोज व्हॅल्यूज हिअर अँड यू विल सॉल्व द एक्सप्रेशन. नेक्स्ट काय, आता the given line is coinciding on x, so I can find out the reflection. So I can find out the reflection along x axis. So what is the T matrix for reflection along x?
1 0 0.
Right. So reflection along x means x will not change, only y will change in its sign. So x is not changing and y is changing in its sign. आता हे रिफ्लेक्शन झालेलं आहे. सो आवर जॉब इज ओव्हर. मग काय करावं लागेल मला, जे मी रोटेशन केले ते मला इनव्हर्स रोटेशन करावं लागेल आणि जे ट्रान्सलेशन केले ते इनव्हर्स ट्रान्सलेशन करून लाईन होती तिथे परत ओरिजिनल पोझिशनला न्यावी लागेल. सो आय विल अप्लाय TR inverse and then I will apply what? TT inverse, T translation inverse. Put करा values. TR inverse ने काय येईल, तुमचा anti-clockwise rotation होतंय with same degree theta. So I will have here anti-clockwise rotation म्हणजे आता इथे मायनस येईल. Then here I will have sin theta. Okay. So next is T translation inverse. So 1 0 0 0 1 0. X is not changing and y is positive now because shifting the line upwards. Okay. So I am having the T total is this. And when this T total will be multiplied with ABC original object, then you will get the reflected object. Okay. So find out this T total. You can note it down in your notebook and calculate it and tell me the result. Okay. So what is the result you are getting? Here cos theta and sin theta. Here cos theta is 4/5. And here sin theta is 3/5. Similarly, sin theta is here 3/5. And cos theta is 4/5. Perform the multiplication, first row, first column. So 4/5, 0, 0. So I will get here 4/5. Next, 4/5. First row, second column, it is 3/5. Then first row, third column, it is 0. Similarly, second row, first column, it is minus 3/5. Then second row, second column, it is 4/5. And this is 0. The last row, first column. So this row, multiplication of these two terms, minus minus will get cancelled. I will get some 3/20. Then this multiplied by this. So I will get here 4/5 into, so minus 4/20. This and last one. Then perform the multiplication between these two. So you can do like this. Here we are not changing the order, but we are simplifying the multiplication. That's it. So you can multiply like this. So cos theta is 4/5. So here I will have 4/5. Then 0, 0. Then minus 3/5 will be there. Sorry. Yes, minus 3/5. Here it is 4/5. It is here. It is minus 3/5. Here it is 3/5. And here 4/5. So first row, first column, it is 4/5. Okay. First row, second column, it is minus 3/5. Here it is minus 3/5. Then 0. Again, first row, third column is 0. Okay. Second row, first column is minus 3/5. Then second row, second column is minus 4/5 and 0. And the last one is 0, 0, 1. Okay. And this last T inverse is as it is. So I will write here T inverse only, as no space is there. Okay. Now perform the multiplication of these two or perform multiplication of this with TT inverse, and then go for the final multiplication. Okay. So I will perform multiplication with TT inverse. That will be easier. Multiply it with 1 0 0 0 1 0 0 1 by 4 0 1 by 4 1. Perform this multiplication 4 by 4 5 into 1. So I will write that result here, so that this multiplied by the resultant, I can get the final answer. So 4 by 5 into 1, it is 4 by 5 itself. The remaining 0 0. Then first row second column, it is minus 3 by 5 only. Then first row third column, it is 0. Then second row first column, it is minus 3 by 5. The second row second column is minus 4 by 5 and 0. And third row first column is 0. Third row second column is, it is 1 by 4. And third row last column is 1. Okay, now do this multiplication. So after multiplication, I will write the coordinates over here. If you have calculator, then tell me the final results of this two multiplication. So here I am having ABC triangle as 2 2 1, then 5 2 1, and then 3 5 1. Okay. Now perform this multiplication. 4 by 4 into 4 by 5. Sorry, 4 by 5 into 4 by 5. First row, first column. That is 4 into 4. 16 by 20 minus 9, 16 by 25 minus 9 by 25. So it is 7 by 25. Then first row, second column, it is 4 into 3, 12 minus 12 by 25, and again minus 12 by 25. So minus 24 by 25. And this plus first row and third column, it's 0. Now the second row and first column, minus 12 by 25, again minus 12 by 25, and 0. So here it is minus 24 by 25. Minus 24 by 25. Okay, then minus becomes plus 9 by 25 plus 16 by 20. Sorry, here it is minus, no? Yes. What we have done earlier, minus only we have taken. First row. Yes, minus only we have taken. Okay. So This second row, it is minus minus will become plus, and this will be minus. So minus 16 plus 9, that is minus 16 plus 9. So minus 7 by 25 it will be, and 0. And last is this row and last column. So 3 by 20 and 4 by 5. So 12 by 100. Minus minus will become plus. This multiplied by first column. So 12 by 100 plus 12 by 100. That is 24 by 100. Then first row and second column. So here again minus 9 by 100 plus 16 by 100 plus 1 by 4. So 9 minus 9 by 100 plus 16 by 100 will become 7 by 100. 7 by 100 plus 1 by 4. 1 by 4 means 25 by 100. 25 plus 7 is 32 by 100. And the last will be this and last one. So you will get 1. And when I will perform the multiplication of these two, am I audible, students?
Yes, ma'am.
Okay. So when I will do this multiplication, I will come to the final result. So 2 into 7, that is 14 by 25 minus 48 by 25. So this has become quite complex. 14 by 25 minus 48 by 25 plus 24 by 100. So convert it to the base 100. Here I will have 48 minus 14. So it is 44 minus 10. It is 34. 34 into 4. That is 132 ka 34 into 136. 136 plus 24. So this is minus 136 plus 24 is minus 112. Minus 112 by 100. Okay. So this is your first x coordinate. X coordinate after this. So if I divide it by 100, I will get minus 1.12. So its reflection will come somewhere here. A point is currently 2, 2. That I will get after reflection. It will lie somewhere on the minus side. No, something is wrong. Okay. During calculation, there will be mistake, I think. But for that, the T matrices are like this. So you can have better calculation and you can get the result in which the resultant triangle will be like this. So this line, when I will
Ma'am,
fold
first
here,
value is minus 1.92.
minus 1.92.
Yes,
No,
ma'am.
somewhere in the calculation it has been get wrong actually. And what is the second value? Y value?
Minus 1.52.
Both are minus only.
Yes, ma'am.
No, it will not happen actually, because this line is passing from positive the first quadrant. That's why this point will be converted, or this point will have the coordinate over here. After reflection, this point will lie here, perpendicular, and then extending in the same direction. This will be also on the same line, perpendicular extended to the next. And here this point will have perpendicular and it will extend this side. So ultimately you are going to get a triangle like this. One point on the opposite side and 2 points this side. So y coordinate may get negative. Maybe y will be negative because y-axis is like this. So this point will come on negative side, but x definitely will not be negative. Okay, let it be. If any calculation mistakes are there, I will tell you where exactly we are getting it wrong. Okay, but anyhow, the procedure is same, that you have to first perform the translation, then you have to carry out the rotation, then reflection, then again rotation inverse and translation inverse. Then you are able to get the final result, and that you will get in this manner. Okay, so whatever the mistake is there, that will be definitely the calculation mistake only. We will have calculation in more neat way. I will solve it on paper and I will pass the picture of that paper. Okay, so with this example, we are knowing now how to solve such type of problems. These problems are never asked in the exam, but to get the procedure and to get the final output drawn, I have solved this particular problem. So no need to worry, I will give the solution of this problem on paper in one its photograph I will send to you. Okay, so that is about the reflection about arbitrary line. This problem was about reflection of arbitrary line. So we will I will clear all these things. Okay, and I will give you the solution. So this particular point ends with the 2D transformation. So whatever the 2D transformation syllabus is there, in 2D transformation, we have seen translation, rotation, reflection, scaling, shearing, combined transformation, rotation about arbitrary point we have seen, and reflection through arbitrary line that we have covered. So we are going to start with the 3D transformations now. So in 3D transformation, all the transformations are same. Scaling is there, shearing is there, rotation, reflection, and translation. Okay, so a little bit modification in earlier 2D transformation is addition of z-axis, because we know 3D transformation, in that we have to consider 3 parameters, x, y, and z. So let us learn 3D transformations. Okay, so in case of 3D transformations, a 3D point can be represented as x, y, z, where x, y, and z, they are the x coordinate, y coordinate, and z coordinate respectively. So any point which is lying in space, it has 3 coordinates, x, y, z. Okay, now its homogeneous representation is x, y, z1. We have seen how the homogeneous coordinate system has evolved. So Instead of a 2 by 2 matrix in 2D, we have got 3 by 3 matrix, and every point is represented as xh, yh, and h, where h is the overall scaling factor or homogeneous coordinate factor. So we have seen that part. Similarly, every 3D point is also converted into a 4 by 4 matrix. So every 3D point is converted into 4 by 1, or here we are having 1 by 4 kind of thing. So 4 lines or 4 rows, 1 column, or if I will write it in the in its transpose fashion, I will have x, y, z, and 1. So this is nothing but your 1 by 4 way of writing a 3D point. So a 3-dimensional homogeneous coordinate is written in this manner. Here we don't lose anything because all the x, y, z values are going to remain same. The main advantage is it is easier to compose the translation and rotation. So we have already seen for translation purpose, we require a 4 by 4 matrix. We require a 4 by 4 matrix where these 3 elements will be now translation along x, translation along y, and translation along z, and this will be 1. So earlier 2 by 2 मध्ये कसं होतं translation? So here we are having 1 0 0 0 1 0, and here tx ty and 1 was there. Same way in 3D also we are having 1 0 0 0 because it is now 4 by 4 matrix. So we have 1 0 0 0, then 0 1 0 0, then 0 0 1 0, and the last is tx ty tz, because we now require the shift parameter, that is the translation along z axis also. So now it is just the comparison of 2D to get the 3-dimensional transformation matrices. So this is your translation matrix for 3D. Okay. So everything is matrix multiplication. Why we need this? Because instead of addition, we want to go for matrix multiplication. And that's why we are writing the 3 by 3 matrix into 4 by 4 in homogeneous coordinate system. Okay. All of you are getting up to this? So 3D
Yes,
3D transformation, in that 3D point is represented like this. And in homogeneous coordinate system, it is represented like this. And 1 by 1 operation we are going to learn now. Okay. So it is written as the 3D coordinate system can be represented with right hand or left hand. So when we use our right hand, then our thumb represent x-axis, the forefinger represent y-axis, and forefinger, or it is also called as index finger, and the middle finger represents z-axis. And whenever we are using our left hand, here in case of right hand and left hand, we need to follow the 90-degree angle in all the 3 fingers. All the 3 fingers will have the 90-degree angle. They are perpendicular to each other like that. And in case of left hand, when we use our left hand, then again thumb is representing your x-axis, the forefinger is representing y, and the middle finger is again representing z, but it is exactly opposite way of representation. If we are using the right hand, then the direction of z is exactly opposite if we are using left hand. If we are using left hand, so that is nothing but only z parameter is changing its sign if we are using right and left hands. So this is 3D coordinate system by using right hand and left hand. Now in 3D transformation, we are having a 4 by 4 matrix like this. So here, remember that it is a transpose, and that's why it is written in this manner. So these three elements are always 0 that we are writing here column wise, and that's why they are there for projection type work. So we will have 0 value always, and remaining this 3 by 3 matrix is now responsible for scaling, shearing, rotation, and reflection. So this 3 by 3 matrix is responsible for 4 operations, and this Tx, Ty, Tz is responsible for translation of 3D object. Okay. So this is the general formula for any transformation, any 3D transformation. Okay, so time is up actually. We will. You have to write the attendance in the chat box. If you have already written the attendance, no need to write it again. Only once you can write that. Those who have not yet written, they can write the attendance, and then we will stop. So the remaining part we will see in the next lecture.